Welcome to Exam Math Keys. This is the part 2 of lesson 2 of our course on indices. Multiplying indices made easy. Add the powers rule. In this lesson, we break down the law that was introduced in the first part of lesson 2. The a raised to power x multiplied by a raised to power y, which is equal to a raised to power x plus y. This lesson will help you to understand why we add the powers, not just memorize the formula. If you master this one rule, most indices questions will become easy. Today, we are learning the most important exponent law. Multiplying same basis. When multiplying powers with the same base, we add the indices. This we learned from the previous 2 lessons. In the last class, we learned that a raised to power x multiplied by a raised to power y is equal to a raised to power x plus y. When multiplying powers with the same base, we add the indices. When multiplying powers with the same base, we add the indices. Consider this example. Two raised to power 3 multiplied by 2 raised to power 2. When we apply the rule, it becomes 2 raised to power 3 plus 2, which is 2 raised to power 5. Another example, five raised to power 2 multiplied by 5 raised to power 4 is equal to 5 raised to power 6. In exams, sometimes you just simplify the exponent only, instead of going ahead to turn this, as 32. You can stop at just 2 raised to power 5 or 5 raised to power 6. Now let's consider this very important warning. Important warning. X raised to power 2 multiplied by y raised to power 3. This cannot be resolved because the bases are not the same. The bases are not the same. Remember that the base include x and y. They are different. So you cannot add 2 plus 3. You can only add 2 plus 3 when you have the same base. Take note of that. That is very important. Because bases are different, the answer remains x raised to power 2 multiply y raised to power 3. There is nothing you can do about the solution. So the answer remains x raised to power 2 multiply y raised to power 3. You can only add indices when the base is the same. Let's look at this example. A raised to power 4 multiplied by a raised to power 6. This is a raised to power 4 plus 6. This is a raised to power 10. What of when you have 3x raised to power 2 multiplied by 5x raised to power 3. You will multiply the coefficients, the numbers, multiply them normally. By coefficient, I am referring to 3 and 5. 3 and 5. This is the coefficient of x, 3, in 3x raised to power 2, and this is the other coefficient. You multiply them, multiply these two, 3 and 5. So when you multiply the two, you will have 15x raised to power 2 plus 3, which is 15x raised to power 5. Multiplying 3x raised to power 2 and 5x raised to power 3. Go ahead, multiply numbers normally. Add indices of the same base. Try the following. Number 1. (4b raised to power 5 multiplied by b raised to power 2). Number 2. 4y raised to power 3 multiply 3y raised to power 4. And number 3. 2m raised to power 2 multiply by 2m raised to power 6. Pause and solve. Now let's solve together. The first one, equal to four times 1. The coefficient of b raised to power 2 is 1. So we have 4 b 5 plus 2, 7. And then number 2, 4 times 3 is 12. Y 3 plus 4 is 7. And the third one, 2 times 2 is 4. M 2 plus 6 is 8. Let us summarize what we have done so far in this lesson. Let us summarize what we have done so far in this lesson. We have learned that when you have same base, add the powers. We also learned that you multiply coefficients separately. Multiply coefficients separately. And we also learned different bases do not add. Do not add. Remember, multiplying, add, dividing, subtract. This connects to the next lesson. When you are multiplying in indices, you add the index involved. When you are dividing, you subtract. In the next lesson, we will learn what happens when we divide powers, and something interesting happens. I want you to comment add if you understood this rule.